All right, let's get started. Thanks again for all of you who've joined. Welcome to today's webinar. My name's Judd Kennedy. I'm the CEO of Willistic Technologies, and I'll be moderating today's webinar. We're very pleased to have Dr. Andy Hughes joining us on today's webinar. As you saw in the invite, he'll be talking us through some of his thoughts and his experience relating to asset management. By way of introduction, for those of you who don't know Andy, which seems like it is increasingly a small number, Andy he's a geotechnical and hydraulics engineer. He has over 40 years of experience in the field of dam engineering, with a particular interest in embankment dams, risk assessment, and industrial archaeology associated with dams, the safety of dams, and the training of engineers. He's also an all reservoirs panel engineer under the UK legislative system and has acted as construction engineer, inspecting engineer, and supervising engineer on hundreds of dams. He's also served as a vice president of ICOLD, which is how probably a lot of you know him, and also the chairman of the British Dam Society on 2 different occasions. He's also advised the British government and regulator on reservoir safety and legislation. Additionally, he provides training courses to organizations and is a visiting professor at Bristol University. So he brings a wealth of experience that we're really excited to all learn from today. He's worked around the world in countries like Ireland, Nigeria, Hong Kong, various Scandinavian countries, South Africa, India, and more. So with that, I think I'll pass the screen over to Andy and let's give him the time to get started and we can hear from him. So Andy.
Well, thank you, Judd, and good afternoon or good morning, wherever you are in the world. But I'm pleased that you could join us to hear some of my thoughts about Willistic and how I've used it on dam engineering projects around the world. And you'll hear that I've used Willistic probably over the last 10 years on a large number of dams, many projects. It's been an interesting route through time and development of the system, and also in the way that we've used Willistic from, as you'll hear, in an emergency situation through to using it more as an asset management tool. So I hope you can hear me. I hope you can see my slides. As I say, it's all to do now with asset management. My experiences have been spread over about a 10 or 12 year period with Willistic, from very early days when the thing was developing. But we've used it on dams. We've recently been doing canals, moving into the mining field with deep excavations and tailings dams. I haven't used it so much in oil and gas exploration or uses in oil and gas industry, but the Americans group has. And then looking at environmental issues, the pollution, and that's in fact where Willistic started way back when, looking at pollution into a stream. And so when I heard about it first, it was really the answer to some of my prayers. Just to give you a little bit of background about the technology, and the other guys on the line in Utah are more au fait with the technology and can answer the more technical questions if they come up. But basically, we apply across 2 electrodes electric current and generate a magnetic field. And then over that area where if there is a flow of water, and we can track individual flow paths, the water is a better conductor generally of the ground around it. And so in very simple terms, if we can trace changes in that magnetic field across that area, then we're actually finding the route of individual leakage paths. And then there's a clever algorithm that works out not only the location in plan, but also in depth. So we can actually plot individual leakage paths or seepage paths or flows of water, both in plan and elevation. And when you're faced with a problem, whether it's in a dam or any other sort of engineering structure, being able to locate a flow of water very precisely at considerable depths is a very useful thing to be able to do. As you can see here in this very simplified diagram, I call it the rugby ball. We put an electrode in the reservoir upstream and an electrode downstream. We connect the two with a circuit wire that goes outside the area of interest and apply a power supply. And then we set up, therefore, a magnetic field between those 2 points. And if you go back to your early days of school, certainly a long time ago for me, you will know about left and right hand rules, and you can work out where the magnetic field is and directions. And then if we have a seepage through that area, that's the better conductor, and it draws that magnetic field to it, and we look for that increase in magnetic field. I'll say a little bit about what the Americans call culture, any influence within the area that could draw that magnetic field to it. So obviously anything that's metal, as we go through the presentation. But this is what the instrument looks like. The clever bits, obviously at the top is a GPS antenna, so we know where we are. The inevitable computer to pick up the data. And then there's various circuit boards in the top box there. The clever bit is in the bottom box, where there are 3 coils which are wound in a particular way, such that they give us very accurate readings of magnetic field intensity, but they're very small. And that's the clever bit, how they are wound to give us 3 coils that are actually transportable, that you've got an instrument that you can move, that you can carry around by one man in the field. And it's that instrument that we use across the site that we're in question, and we take a magnetic field reading at something like usually 5-meter intervals across the site. We can vary that, and the spacing gives us better definition. The closer the indication, or the closer the points of survey, the better the definition of the survey. You can see here one guy using it up on the side of a reservoir. Patented. The important words there, I suppose, are non-invasive. We don't drill any holes. Generally, we don't have to drill any holes. It's all done on the surface. We find these subsurface water pathways, and it uses proprietary software to work out in essence where the depth of that flow is. So as I said before, individual seepage paths from your reservoir or from your receptacle through to downstream or into your excavation or whatever you're trying to find. Generally, we complete surveys over a week for a dam. It would be a day or 2 to set the survey up, a day or 2 to take the survey down, and then a few days in between to do the survey over the surface of the dam. And we usually take readings not only on the dam itself, but some on the water as well. And the advantage of working across the world, whether we're going east or west from the UK, means that we can use that time difference to our advantage. We're able to send the results back to Utah. They look at the results while the teams are asleep, and they can redirect the survey on a day-to-day basis. So we can almost tell you in real time what is happening within the dam. And we can move the electrodes to the best advantage to get the best from the survey. And so it's a very useful thing, really, to have the time difference and have people on hand to look at the results as they're coming in. We're looking for a contrast. We're looking for a flow, and you can see on the bottom, the second bullet point there, metal objects can be identified. In fact, we've been on dams where people have said, no, there's no pipework associated with this dam, or there are no cables across here, and we've actually found pipes that people didn't know about. But ideally, we need to know about them, and then we can model out, filter out in the model, the effects of those elements of culture that would pull the magnetic field to them. All of our operators are trained. It can be quite complex to set up the site, set up the problems, and understand when problems are occurring to get high quality readings. And so it's important that our operators are trained and certified by the Utah facility. So going back to my experiences, as I say, as an engineer, my prayers were answered. Often we're faced with a situation where we have a leaky dam and we don't know how serious it is. We don't know whether the water's going under the dam, around the dam, or through the dam. We don't know whether it's getting worse or not. We may be lucky enough to know where it's going in, and we may know where it's coming out, but we don't know where it's going in between. And therefore, if we do worry about it to an extent where we're doing remedial works, we often over-egg and overestimate how much we're going to repair. So when somebody tells you, I can tell you exactly where the leakage is, I can plot exactly where through your waterproof membrane, your barrier, where the water's going, it was music to my ears. As with all things new, there was certainly a degree of skepticism on my part. And then when I was trying to advise other owners to use this methodology, there was a lot of skepticism. You know, I don't believe that there's anything out there that will give us this sort of result. Initially, there was a significantly high cost, higher than most people had in their budgets, and that was also, again, a stumbling block. And so over the years, we've tried to break down the barriers, the skepticism. I've talked quite a lot around the world about various projects, and those projects now have a lot of validation associated with them. Owners have validated what we've said from the surveys by drilling boreholes down to the leaks and doing the remedial works. The instrument has improved, so the time involved in doing the survey has reduced, so the cost has started to come down. And we started to educate people that willow stick is a technique along with others. There are other techniques, but personally you end up as an engineer with a preference, and willow stick does have a few constraints within it, and some might be better than others for most. But from my point of view, willow stick is the most useful technique that I have seen over the years and I've used extensively. And so that recognition that it's a useful thing, the prices come down and people understand what's happening and they gain confidence has meant that it's being used more and more around the world, and more by owners who have tried it at least once. And of course, one of the big benefits of being able to say precisely where a leak is, both in plan and innovation, is that you can do targeted remedial works. And I can almost guarantee that you will save 10 times over the cost of any survey when you're able to focus and target remedial works, rather than guessing and overestimating either in longitudinal extent or in depth. And one of the big issues, as we'll see when I talk more about risk assessment, is that you take out of the equation all your concerns about leakage, about internal erosion, and the uncertainty associated with that element of probability of failure, because you really do have a true understanding of how your dam is behaving. I found this slide quite funny at times. So, you know, what keeps an asset manager up at night? The guy who can't sleep, not knowing what I don't know. The stuff I do know, I know how to handle. The stuff I don't know how to handle it. And of course, these days, you've seen, even a few weeks ago, I'm going in a couple of days, you know, we're still having dam failures around the world in the 21st century. And if we are able to assess our dams, use a number of tools in the toolbox to assess using surveillance, the condition and the behavior of our dams, then hopefully we get early warning of a problem and we can intervene. It's all about detection. And when we look at the use of this technique in asset management, it's a repetitive process where one can assess a dam perhaps in one particular year and then go back 5-10 years later, reassess it and see that there hopefully has been no deterioration, but in some dams we do see a deteriorating process taking place, and then you can intervene, because obviously the repercussions associated, the consequences of failure are large: lawsuits and fines and penalties and even getting locked up, and one just doesn't want to go there. So how have I used willow stick? And it's really been a progressive story. I started off using the system on the left-hand side of this screen, reactive. People would have a leak and somebody would say, Andy, we've got a leak, help us find it. How do we deal with this? How do we repair it? How do we stop that leak happening? So that's what I've called reactive, where we then go in quickly, find the leak and plug the leak, basically. The middle one is where people, having got some understanding of the system, have then said, well, let's carry on looking at some of our other dams. And I'm worried about this one. I've just got a bad feeling about this dam, or we're seeing leakage downstream of this one. Not sure whether it's coming from the dam, not sure whether it's coming from the hillside. Just give me the confidence that my dam is behaving in an adequate way. And so I've called that proactive, where owners have then started looking a little bit further than the immediate problem they have. And then, from my point of view, a very interesting phase that we've moved into is where we've used it for asset management. Now, some of you will have heard and been involved with PRA, probabilistic risk assessment, where when you're faced with a situation where you've got 80, 90, 100, 200, 300 dams in your portfolio, where do you spend your money first? Which one is the most important? Do you deal with it just because you've had a report on that particular dam with no thought about whether the dam next to it is in a worse state or not? So how do you prove to a regulator, or indeed prove to a courtroom, that you've put your limited resources and limited finances into the right place? And so probabilistic risk assessment has become one of the buzzwords around the world. But I'm going to just make some warnings about its use and my concerns about how I have seen it being used. I've done it myself for a number of clients, and we've done some very useful portfolio risk assessments as a screening tool and as an assist to them in their capital planning. But you have to bear in mind it does have some limitations. So it is the modern buzz phrase. Everybody says, well, if you'd done risk assessment, you would have understood the failure mode, and you would have understood this, and you'd be able to stop the failure. And be aware these days, when anything happens around the world, people know about it very quickly, and people share information across the world, and in a courtroom you will be compared with best practice around the rest of the world. But is risk assessment really a useful tool? Well, yes, it is, but it is surely just one of the tools we have. And I've put there the bane of our lives. I'm lucky enough to have moved out of a situation where I was having to do lots of bits of paperwork. And if we're getting to a situation where risk assessment is ruling us rather than us ruling it, then I believe it's gone a little bit too far. But it certainly does have a use in ensuring the safety of our dams. So we can look at an individual dam, or we can indeed look at a portfolio. And very often, and I fear for the future to a degree, a lot, and one of my areas you hear Judge talking about was training. And I worry about the training of young engineers. But the older engineers do exercise pragmatism and judgment based on their experience. The more we move to a risk assessment process and driven process, the more we are likely to fall into the trap of becoming very prescriptive. And I believe we will get to a situation where people will want things to 15 decimal places. And I do ask you to think about what I'm going to talk about next, which is the levels of uncertainty. So do the numbers mean anything? You've heard that age-old phrase, rubbish in and rubbish out. And this is where we must train the younger engineers that they must understand how precise our profession is, or how imprecise it can be, how much of an art it is rather than a science in places. And they must understand the levels of uncertainty associated with it. Because if we don't do that, then you may not be comparing like with like, apples with apples, oranges with oranges. So risk assessment has to be a tool. It's part of our toolbox, and there are many tools within our toolbox. And in general, I think this phrase holds true, that all the information we get, it's only as good as, the output is only as good as the information from which it's derived. And there will be levels of uncertainty. So in very simple terms, when you do a portfolio risk assessment, there are, take this slide here, I'm showing 5 dams with different types of failure modes: internal erosion, some sort of piping failure, instability, slope stability issues, and then some sort of foundation failure, leading to a summation to give us a total probability of failure. And you might have various other failure modes associated with that. But from my experience, the most likely and the highest element within that total probability is associated with leakage, with seepage, with internal erosion processes. And so you can see that it's going to be driven, certainly in the UK and Western Europe, it will be driven generally by internal erosion worries. And there are lots of people who are doing lots of work in internal erosion. And my question would be, is it always the largest issue that we should consider, or is it more associated with the particular formation of the dam and how it's constructed? But what you do then is you plot your assets onto an FN chart, which relates the likely loss of life to the probability of failure. And in general terms, different limitations on the different lines in different countries, but you have an acceptable region, an unacceptable region, an acceptable region, and then in between the ALARP region as low as reasonably practical. And if you show this sort of diagram to an owner, to a board of directors, they'll say, I don't want any dams up in this unacceptable area, you've got to move them. Well, how do you do that? Well, you either have to move the probability or you have to move the people. So risk assessment, as I've said, is one of those tools, but understand that level of uncertainty. If we're able to look at that equation before we use WillowStick, and then do a WillowStick survey and say, well, actually, there are no leaks through the dam. There are no flow paths. Nothing is passing through the dam. Nothing is passing under the dam. Nothing's passing around the dam. Then can we reduce that probability of failure due to internal erosion down to some manageable number? I've left a residual number here, because what that does then is it immediately moves it down from the unacceptable range down into the ALARP range. So just by understanding and reducing that level of uncertainty, we're able to influence where this sits in the portfolio. Now, when you're sitting with a series of reservoirs close to infrastructure, close to housing, then you may not have the areas to be able to do remedial works, and you certainly won't have the acceptability, certainly in the developed Western world, etc., to move people away from an area. You might do it, you might buy out 1 or 2 houses if it's a small community, but when there are large communities around, then you certainly wouldn't contemplate moving people. So the only way to move it on that chart is either to try and find land, and you might be hemmed in by other bits of infrastructure to put some sort of stabilizing berm or cutoff, or you have to just look at those levels of uncertainty. So that's the warning about risk assessment, really, that you just have to be aware all the way through the process of where your levels of uncertainty are. And in 2002, I dealt with an emergency, which was some form of internal erosion. At the time we did the portfolio risk assessment of about 160 dams, the dam in question was number 22. The night it happened, it became number 1. And that level of uncertainty suddenly was clarified because we suddenly found out a lot more and thought a lot more about that dam than we ever had done before, and obviously it had popped to the surface as the most likely dam to fail within that portfolio. Now, just to show you the application, and again to give a warning about how one interprets a particular situation on one of your dams. This was a survey that I was asked to do in Austria. I got a phone call from an Austrian firm, and it's written up in various ICOL papers. But Dürlesboden is a very large dam up in the Austrian Alps used for hydro generation. It's a significant dam. It's got a significant reservoir behind it, and it's very important in terms of generating hydro for the company in question. And they rang me up and they said, we've heard about this technique, we've heard about you. Could you come and talk to us about our dam called Dürlesboden up in the Austrian Alps, which I went to look at. It's a beautiful site. It's a big dam with a central clay core, and you can see on this cross section a cutoff. But you can see here that the dam sits on a significant amount of alluvium, and in fact there is not a complete cutoff. And when they briefed me about this particular dam, they told me that within this significant depth of alluvial material in the bottom of the valley, there is a silt layer, which is not continuous because we drilled lots of holes into it, but it is that silt layer which ensures the water tightness of the dam, although it operates as a steady seepage dam with flow taking place below the dam almost on a continuous basis. So we haven't got a distinct cutoff other than it goes into that silt layer. And we know that the silt layer has imperfections and it has holes in it. So as I say, it's a significant dam. The consequences of failure are large, both in terms of life loss and in terms of the commercial loss to the company. Built, quite a young dam, built in 1967, 85 meters high. As I said, the geology was complex, 130 meters of alluvium, so you're not going to get a cutoff into and down through into the bedrock. And so it goes down to about 50 meters into that silt layer with a controlled seepage situation. It was heavily instrumented at the time, but what happened over a series of years was that more and more seepage took place beneath the dam. And water would well up at the toe, and so the Austrians would infill the valley downstream, put a few relief wells in, and then it was okay for a little while. They put in about 50 piezometers each time it happened, but then a year or two later the same thing would happen, so they infilled a bit more of the valley downstream. And they did this on about 4 or 5 occasions until they got very close to a road that was crossing the valley downstream and they couldn't go any further. But then in 2015, there was a significant increase in the flows downstream, which gave them some concern and hence a call to me. I went over to Austria. There was a significant flow. It was turbid and it was giving everybody a lot of concerns. But on this occasion, again, the owner, and it's happened on many, many occasions, the owner told me what the answer to the problem was before we'd even done the survey. I was invited to look at all the geological reports, to look at the geology, to assess the piezometric levels, to assess what they've done. And in fact, as with many other cases, I've just said, well, just let me do a willow stick survey first. And so we did that. We went and did a willow stick survey, and subsequently, the company did other types of geophysical surveys. And then they did some boreholes to prove what happened. So I was given the solution to the problem. The problem was in the silt layer. The silt layer was fractured, it had defects in it within the center of the valley, and that was what was causing the flow downstream. And therefore, just tell me where I have to seal that silt layer in the middle of the valley. That itself would have been a difficult problem to do, but nevertheless, I was told that was the problem. There was a huge amount of data, huge amounts of piezometric data, huge amounts of geological data, umpteen reports from geologists, and it was a lot of information. But we ignored all of that, I'm afraid. We went out and we set up 4 different surveys. Unfortunately, all the piezometers had metal pipes associated with them, so there was a lot of culture that we had to work around. But we went out with an open mind as always, thinking, well, is the leakage through the dam? Is it through that silt layer? Is it in the bottom of the valley? Is it around the side? Where is that leakage? Not very hospitable conditions, but beautiful work. There's the instrument sitting out on the dam, and that's the instrument the guys would walk over the full face of the embankment and the abutments and the area outside it, and taking instrument readings at about 5-meter intervals. You can see here a typical layout. So you can see here what I call the rugby ball. You can see the electrode sitting in the reservoir. You can see an electrode that was put into a piezometer out on that right flank of the dam, and then the connecting wire between them has to go well outside the area, and that's why it takes a few days to set up the system, and we often have to go onto third parties' land to be able to do that survey. But the orange line going off the slide to the left and out under the legend on the right is the wire that connects those 2 points together. And you can see between the two is the onion shell or the rugby ball that shows the theoretical magnetic field if it's not disturbed between those 2 electrodes. And you can see each of those red points on the dam and up onto the right abutment is where we've taken a reading. So we've taken some readings on the upstream face, the crest, the downstream side. And by this stage, we were homing in on the actual problem. And so we were doing readings up onto the hillside, up onto that right abutment. And you can see down in the toe of the dam, the base of the dam there, the various blue points where water was arising before it met the road downstream and all the piezometers. So the whole of the valley downstream of the toe of the dam down to the main road had been infilled and various relief wells put into that. So the owners were getting to a stage where they had nowhere to go. They had to really try and solve the problem once and for all. This is the sort of data that you will get. This is very much influenced by a tunnel, a very heavily reinforced culvert tunnel down that right-hand mitre, which is the black and the green there. And so that culture has to be filtered out. So we compare the magnetic field that we would expect to get if there was no disturbance, with no water there, with the magnetic field when we have a disturbance. And so this is what is predicted. No disturbance. You can see concentric circles effectively. This was what was observed, and when you put the two together, you get a different result. And so what we were able to see was that there was no major seepage through the silt layer at all. We could categorically say with total certainty there was no seepage through or under that dam from the reservoir. But there was significant seepage through the right abutment beyond the end of the dam. The water was tracking around. So here's a cross-section of the dam. You can see the red line is the gallery that runs below the dam. There was an adduct. The horizontal red line on the left-hand side of the screen is an adduct that was drilled into the hillside at the time of construction. And the Willow Stick survey showed at that in the triangle between the horizontal adduct and the adductors, the gallery that's running down to the toe of the dam, there was a leakage, there was a seepage there. Effectively, the grout curtain had not been extended far enough into that hillside. So we did the survey and I went away. And really, the owner, I think, would admit now that he didn't believe the results. He was still convinced that the survey and the silt layer were not correct, or the survey was not correct, and the problem was in the silt layer within the center of the embankment. And I didn't hear anything from the owner for about a year. And what they were doing was they were trying out other geophysical systems, none of which gave the data or the information that the Willow Stick survey had done, but they also drilled some 900 meters of boreholes into the area of that right abutment just to prove what we did. And they rang me up a year later and said, "Can you come back to Austria?" And I said, "Well, why?" And they just said, "Just come back to Austria and you can use that English phrase, 'I told you so.'" So I went back to Austria and we identified, sorry, I'll just go back to that one. We identified a zone because when I went into a room of 5 geologists, they said, "We've drilled 900 meters of boreholes and you're absolutely right. We have found the leak. We can see it tracking down the outside of the gallery, down to the bottom of the dam. It then goes under any fill we've put underneath the dam, and it pops up in various places. So can you tell us from your survey what sort of zone we need to grout?" So we went back and looked at our results and we said, well, you do need to remediate. You have a significant flow in a relatively small area. And we defined a length 150 meters long by 100 meters deep. And within that, actually, it was a much smaller area that was actually passing the flow. It was in part of the original, I should say, grout curtain. Sorry, I should say grout curtain rather than group curtain. We found that the grout in the original grout curtain, when they looked at their drill logs and looked at the drill arisings, that some of the grout in the grout curtain had deteriorated with time. And so we said that they should reinforce that end of the grout curtain, but then go outside it as well. So the owner's reaction was very surprised. If I say they didn't believe me, that would be quite true. They then went back, and with the knowledge that they had about where the leakage was, and then using the piezometric data and looking at levels of conductivity in the water, they themselves were able to sift through that information in a much more educated way and come to the same conclusion that we did, and very different to their original conclusions. So they looked at that information again, as I say. They did try other geophysical methods, EM and various others, and didn't find them as informative as the Willow Stick process. And that's why they came back to us and said, right, let's just have a look at the area we have to grout. They drilled these 923 meters of core, and in that they assessed how to grout, what grouts to use with a grouting specialist, and showed that they should do part of the original curtain, but very much more outside that curtain to cut it off. So they came to the conclusions and allowed me to say to them, "I told you so," and that it was a very useful thing. They'd used these boreholes and other techniques to prove what we'd said to them, but also to define the work as they went forward. And then they did this very targeted remedial work. So it removed all of that uncertainty and it's given them back a dam where they know they haven't got a problem. And all that worry about relief wells and seepages and boils and water coming out of the toe has now subsided because they've gone in and repaired it. Here you can see it was a very relatively small area. You can see the anomalies caused by the culture, but we told them exactly where to do it. So in general terms, whatever we're doing, as I say, with risk assessment, be careful, understand the levels of uncertainty that are there. Techniques such as Willow Stick can reduce that level of uncertainty and allow you to have confidence about your dam. You can then reprioritize your portfolio and spread your resources to other needy dams. And then if there are works to do, you can do targeted remedial works, reduce the probability of failure, and then concentrate on the others. So once you've done that, once you've done your asset management, you've done your targeted remedial works or get a clean bill of health to say there isn't a problem, then you can sleep easy at night. in conclusion, I would say it's a technique that I have gained confidence in over the years. It works. We have many cases with references from clients where they say this is a fantastic process, and we've got many references where they've done this validation exercise. There are some limitations in different areas. We had an interesting case a few months ago, a year or two ago. We were doing a dam in Sweden, I think it was either Norway or Sweden, and we couldn't actually get a current to flow between the two electrodes, and we thought the instrumentation had failed. We were just about to ship other instruments from the States, not the actual WillowStick instruments, but the other generating instruments, the control instrumentation. And then we tried it in a bucket. We put the water in a bucket and put the two electrodes in a bucket, and we couldn't get electricity to pass between the two electrodes. And when we suddenly realized that the water in the reservoir had no ions in it at all, it was almost like distilled water. So we put some salt into it and everything worked. So there are limitations. If there's a lot of metal work around, we'll have problems. We do need a flow. We can track, as I say, in plan and elevation, and we can give you the relative size of the flow rates, but we can't tell you the exact flow rates. We can tell you one is more serious leakage than the other. It does remove this total level of uncertainty. It gives me great pleasure to say to a client, you haven't got any leaks. There's nothing to worry about. Or if we do say there's a leak, we can tell them exactly where it is, and then there's targeted remedial works. And then they fix it. Then we usually survey it again and show that their fix has been successful and that the leakage has been cut off. And in that way, you can attack your capital program on your assets in the right way. You can put the limited resources in the right places, and you can achieve significant cost savings. So that's about it from my point of view. That's my contact details. As I say, we'll take some questions now, but if there's anything you want to know or you want some references or whatever you want to do, please get in touch. So I'll hand back to Judd, and he will manage the question and answer session if you have any questions.
Perfect. Thank you very much, Andy. That was extremely informative. I'm sure everyone learned and appreciated what you said as much as I did. We have quite a few good questions that have come in. We'll try to get to all of them if we can. If not, like I said, we'll follow up separately via email and answer your question specifically. So just to start out, one person asked that, just pulling this up right here, excuse me. Andy, you mentioned you can identify, WillowStick can identify flow paths very deep. Do you have a specific number in meters or feet that you can still identify preferential flow? Andy, do you want to take that?
Well, yeah, and you can answer as well. But we've been down at 200 to 300 meters and identified individual leakage paths. One of the jobs in Sri Lanka I did, we were down at about 100 meters. So 100, 200 meters is where I'd be comfortable with, certainly, and at a high level of accuracy.
Thank you. And just to add to that, and kind of from the WillowStick perspective, we've obtained very good results at sites down to 1,000 feet, over 300 meters. That's what our engineers make me say, because they're always erring on the safe side. We've had several projects with clients here in the US where we've gone far past that. And so it somewhat is site dependent, but the safe number is down to about 1,000 feet where we can identify preferential flow paths with a high level of accuracy. Another good question we have is someone, Andy, specifically, this is for you, said that you mentioned that you have experience using other geophysical techniques. Can you talk a little bit about how WillowStick compares to those and why WillowStick has become kind of your preferred method?
Yeah, that's an interesting question. I've used various, or others have used it for me, temperature probes, electrical resistivity, ground proving radar, various techniques. What is really highlighted the benefit of this system is that it is non-intrusive. It's very fast. It's accurate. There is very little interpretation that we have to do. Obviously, the guys in Utah do the analysis, but I've gained so much confidence in the technique over the years. Whereas all of the others, you have to spend so much time doing it. It's often intrusive. There's often all sorts of inconsistencies in different techniques, and I don't want to criticize any in particular. But to me, this Willow Stick has floated to the top as the best. And as I've said, because of the way that we use it and the time difference, we can almost tell you on a day-to-day basis exactly what the problem is and whether you have a problem or not. And that time difference, as I've said before, we can change the position of the electrodes. We see an issue, it might be on the fringe of the surface, the survey area that we want to do. And therefore we move the electrodes to just cover that area a bit better. Many of the techniques you wouldn't be able to access up a steep abutment as we do with Willow Stick. You wouldn't be able to do temperature probing up on a steep abutment with any ease without huge amounts of work to do that. All I have to do is get a guy there and I start getting results. So the flexibility, the accuracy, the non-intrusive nature, the speed of reaction are all very positive plus points for me. We all have our favorites, whether it's in materials used in construction, whether it's a technique of this type, but it's certainly come out as my favorite.
Great, thank you. Another good question we have is a few people have asked about having access to the recording of this. We will send out the recording of this webinar within a couple hours later today to all of you and everyone else who registered. So if you want to share it with anyone, a few people have indicated they'd like to share it with their team or their manager, feel free to do that. And then if you have any questions or like any further information, feel free to reach out to Andy or myself. You have all of our information via the emails that we sent out to invite you to this. So good questions there. Another question.
If you want me to appear in person, as long as it's in a nice place of the world with first-class airfare, I'll go anywhere.
Good to know. Thanks, Andy. Another good question we have here. Andy, if you want to take this, have you seen a difference in the results when applying Willow Stick to seepage in fractured rock versus soil?
Not really. I'm entirely confident with both. We have used it on concrete dams, on concrete foundation, on rock foundation with fissures, clay-filled fissures, and I'm supremely confident that we identified an individual seepage path through fissured rock. We've used, as you've seen there, Willow Stick on earthfill dams with clay cores, on very complex geology, on deep alluvium, very variable soils, and come out with very definitive results. We've used it on canals with canal liners and used it effectively there, and that's an area that we may be developing further to try and speed up the analysis of hundreds of kilometers of canals. Certainly, I don't have any concerns. One of the first jobs I did with Willow Stick was a very interesting dam in Sri Lanka, and they'd spent 66 million over a period of about 10 years from first filling on trying to stop what was one leak at 9 cubic meters per second. And when you have a leak from a dam that's 9 cubic meters per second, it's not a comfortable situation. But they'd spent many years, and as I say, 66 million pounds trying to solve the problem. They had an enormous number of expert reports on the facility. They'd done drilling into the hillside in an adit. They'd done grouting. They'd thrown 500,000 cubic meters of clay into the reservoir to try and get it to self-seal. But they were really looking for a needle in a haystack, and they asked me to go and have a look at it. And again, we did a Willow Stick survey, and we showed that there was one. It was built on a karstic foundation. They knew it was on a karstic foundation and they dealt with it. But we found one leak, one passage, which we defined as about 1 meter square, through one area of a limestone hillside off to the right abutment. And nothing through the dam, nothing through a rockfill dam, and nothing through the foundation, which was soil. So I would have supreme confidence that it's equally applicable to a rock foundation, a fissured rock foundation, as opposed to an earth-fill, alluvium-filled valley bottom.
Thank you. We've seen a few questions come in on the price and cost of this side, and I'll kind of handle this, and Andy can add anything if he wants to after I'm done. But you know, it's hard without seeing specific sites to give you guys an idea of cost. I will say, and Andy mentioned this in his presentation, that you know, when we first started out, the cost was much higher. To give you an idea, for the first couple of years, one reading, one measurement station, if you remember Andy's slide, one of those little red points, took 15 minutes, and currently it's 8 seconds. And so we've come a long way, and with that, our price has decreased significantly as well. And so often when I'm presenting to people at conferences, I'll get people who come up to me after and they'll say, you know, it's great, I understood, I've heard great things about you guys, or I've worked with you before. I've also heard that you're super expensive. And so, you know, I just want to dispel that myth now. We were at one time, and our prices come down significantly. Obviously, there's an element of value associated with it, and Andy talked well about that. But that was kind of the long answer to these questions. The short answer is we'd love to take a look at your site and provide you a proposal, and we can get kind of more in the details there with that information. I know we're coming up against time. We have a few more questions, a few that we may not get to. I think this one is a good question for Andy to answer. In Northwest England, we have just done a dam remedial with a steel pile system along with a weighted filter. Would this affect the results of a Willistic survey, or can a structure like this be filtered out?
Yeah, it could be filtered out. We've just done a job in the south of England, southeast of England, so diametrically opposite, where we showed 3 leaks. The client in that case decided to use a piled situation as the cutoff to that leakage. I'm doing a similar job in Yorkshire at the moment, where we're putting piles through the core into the underlying foundation to cut off leakage. In the case in the southeast, the client then said, well, prove to me that the leaks have been sealed. And so you've then got, you know, a great big wall of sheet pile, and as I said, you know, the magnetic field will go towards the sheet piles. But actually, when you place the electrodes at right angles to the sheet pile wall, so just by positioning the electrodes in the right position, we can filter out the wall that is crossing the magnetic field. And it's when we know about culture, when we know what metalwork is there, we can filter it out, whether it's a pipe within a tunnel, upstream, downstream, whether it's a sheet pile wall along the line of the core, we can filter it out. And so we ask people what culture is there. And so they will tell us, and often we'll find some more. It might be in Sri Lanka, for instance, there was a cable running along the crest of the dam, taking power to the floodlights and the street lights on the top of the dam. That was picked up in a job I did in Lincolnshire. The owner didn't know he had a metal pipe in the dam, and we told him, you've got a metal pipe in the dam. So we can find it, we will find it. If we know it's there, we can filter it out, but we can deal with that. There's not a problem.
Great. So with that, I think there are a few questions left, but I think we'll leave those. They're specific enough. We'll leave them to answer specifically in emails to the individuals. I'd like to thank Andy, first of all, for sharing your insight and expertise. We appreciate that. And thank you all for joining today. Once again, if you have any questions, would like us to take a look at a site or anything else, please feel free to reach out. It was nice talking to you, and we hope you have all have a good day.
Thanks for listening, everybody.